Hi students, today we are going to see some more problems on friction. The concept is block on block. Okay. Topic is block on block. So let us see this example. There is a block B on which another block is placed. Let it be A, which is connected with the help of a string, and the other end is connected to a fixed support. This is a ground. Okay, the block B is placed on the ground. Now this force is applied on this block. Let it be F. Now this is the diagram. Mass of A. So what is given in the figure? Given mass of A. A has mass 100 kg. Block is placed on mass of B is 200 kg. 200 kg as shown in the figure. The block A is attached to a string to the wall. The coefficient of friction between A and B. So mu between A and B is 0.2. Okay. And coefficient of friction between floor and B is 0.3. Okay. Then find the minimum force as shown in the figure. Shown in the figure. Okay. Mu. Then calculate minimum force. Calculate minimum force required to move the block B. Take G is 10 meter second to the power minus 2. Okay. So this is the instance. So this block, upper block is fixed. Okay. So this upper block is fixed. Let us see this problem. Okay. So upper block is connected to a string, and that in turn is connected to a fixed support. Block B is, A is placed on block B. There is friction between A and B. Coefficient of friction between these two blocks is 0.2. Coefficient of friction between block B and the ground surface is 0.3. Mass of block A is 100 kg. Mass of block B is 200 kg. Okay. Now what is the minimum force required to pull this block? That is the problem. Okay. So you find the, so first you draw this direction of frictional forces. Okay. The first step is direction of frictional forces. As I said, friction is a self-adjusting force. Its direction as well as magnitude changes with respect to applied force. Okay. So first you find the direction of frictional forces. Direction of friction. So block A. Okay. So block A, FBD of A. Okay. What is FBD of A? What are the forces acting on it? Tension in the string, it will be like this. And the block B, first I will draw the FBD of B. Okay. FBD of B. So B, this is A. So what is the B? What are the forces acting on it? F, external force. And its frictional force is opposed. So it is a frictional force opposes in this direction. So let it be F1. And there is a friction between these two blocks. Let it be F2. Okay? So the forces acting on the block are F1 plus F2. They are acting in the same direction. Okay? These two, F1 and F2. F1 is the frictional force between the block B and the surface. It opposes its motion, and the frictional force A and B also opposes. Let it be F2. Okay? So F1, F2 are in the same direction on this block B. And this block A in turns, this frictional force also forms, it obeys Newton's third law. So I said forces always exist in pair. So the frictional force is also the frictional force between these two. On the block B acts in this direction, then the block A tends to in this direction. So the frictional force on the block A is in this one, that is F2. Okay? So these are the FBDs and the direction of frictional forces on this diagram. Now second one is you find the limiting values, frictional force magnitudes. Okay? Magnitude of frictional forces. Magnitude of frictional forces. Okay? Magnitude of friction. So first you take the F2. F2 is equal to what is the given formula? Mu into N. N2. N2 is the frictional force acts on this. So the weight of this block, mg down, mass of the block A, and in turn it exerts a force N. Let it be N2. Okay? So this N2 is the normal reaction exerted by this block B on A. Okay? So that N2 is MAG. So the frictional force F2 is mu. What is the mu value? 0.2. What is N2? mg. Okay? I will write mg. Next step I will substitute the values. So F2 is equal to mu is 0.2. Mass of A is how much? 100 kg. G value, let it be 10. So this will become 2 into 100, 200 newtons. Okay? So the frictional force between A and B is 200 newtons. Now I want a frictional force between F1, between B and the ground. So F1 is equal to, I will write here, F1 is equal to mu N1. So what is N1? The force exerted by this ground on the block B. So this B exerts a force, in turn its weight, mass of B into G, its weight down, and its normal reaction is acting on B by the ground is it is N1. Let it be. So frictional force is between these two is mu N1. And one more force is acting on this one. N2 is the force exerted by this one on the A. A exert in turn same force on B. So this is N2 will act in this direction. So N1 is equal to M2G plus N2. But N2 is equal to mu AG. So what you will get? Mu into N1 becomes M2G, M mass of B into G plus N2. Okay? So that is mu into mass of B into G plus what is N2? N2 is mu AG. So A into G, mass mg. So you take common G. So what is mu? Mu is 0.3. What is mass of A plus mass of B? 100 plus 200, 300. What is G? 10. So this is 0.3 into 10, 3. 3 into 300, 900. So this is 900 newtons. That is F2. Now you check this one. The minimum force required to move the block is, to move this block. So next step I will write here. Next step. Force required to move the block. Force required to move the block. To move the block B. To move the block B. It should be, F should be greater than or equal to F1 plus F2 from this diagram. Okay. So F1 plus F2. So we want minimum force. So F minimum is equal to F1 plus F2. What is F1? F1 is 900 plus F2 is 200. So total 1100 newtons. So minimum force required to move the block is, answer is 1100 newtons force. Okay, clear? Take this. Okay, you take another problem. I will draw the diagram first. So there are two blocks. Block B, whose mass is 20 kg. Whose mass is 20 kg. A block A, whose mass is, block A, whose mass is whose mass is 10 kg. 10 kg is placed on the block B. Here the coefficient of friction between these two, mu s is, coefficient of static friction is 0.2, coefficient of kinetic friction is 0.1 between these two surfaces. Between these two surfaces it is smooth. So the ground is smooth. And now see this diagram. In the given figure, the block A is placed on the block B and both are placed on a smooth horizontal plane. Assume lower blocks to be sufficiently long. Assume lower block is sufficiently long. The force F pulling the block B, so this is the force pulling the block B horizontally. So horizontally increased is increased according to the law, is increased according to the law. F is equal to 10T newtons. A. Under that we have three questions. First one, A. When does block A starts slipping slipping on block B. On block B, question mark. What is the what will be the force F? What will be force F? F and acceleration just before slipping. Just before slipping starts. Just before slipping starts. B. What F, when F is increasing, increased beyond the value obtained in part A. And what will be acceleration of A? What will be the acceleration of A? Acceleration of A, question mark. C. Draw the acceleration time graph. So draw the acceleration time graph. Okay, so this is the problem. Okay, so we check this problem. So this is the problem. Let us see. Block B is having the mass 20 kg. Block A is having mass 10 kg, which is placed on block B. There is a frictional force between the block A and B. Coefficient of static friction is 0.2. Coefficient of kinetic friction is 0.1. A external force F acts on the block B, that is lower block. This force is a variable force. So that force varies. It acts horizontally according to the law F is equal to 10T. Based on this law, where T is the time, acts on this. And when does the block A starts slipping on the block B? That is the first question. What will be the force F and the acceleration just before slipping starts? Okay, when force F is increased beyond the value obtained in part A, what will be the acceleration of A? Draw the acceleration time graph. Okay, these are the things we have to solve. Okay, now see, first you go through this FBDs and you draw this part. So this is the question. So see, I will draw. Assume lower block is sufficiently long. The force F is pulling on the block B. Okay, horizontally, and it is increasing according to the law. Okay, so I will rub this space. I need this space. Okay, now the step 1, you draw the direction of frictional forces. Direction of friction. Direction of friction. Frictional direction of friction. First you represent this. So the block B, you draw the FBD of B. Okay. So what is FBD of B? The force, external force F acts on it, and it is opposed by frictional force, that it is F in this one. Okay, that is the FBD of B. And this frictional force, when it is static, it has Fs, limiting value, and when it is moving, it slips, it has a frictional value, kinetic. Okay, so this is the FBD, and two more forces acting on this, that is vertically, normal reaction, let it be N1, the force exerted by the ground on it, and its weight mg, mass of B into G. So this is the FBD. One more force is there on this, that is the force exerted by this 10 kg on 20 kg block, let it be N2. Okay, that force, let it be N2. N2 is the force exerted by the block A on B, that is vertically down. It is nothing but weight. Okay, so now you draw the FBD of A. Okay, now this block A is moving along with the block because of frictional force. So on B, frictional force acts in this direction. On the block A, frictional force acts in this direction. So this is Newton's third law. So the frictional force also forms action-reaction pair. So the frictional force on B acts towards left side. The same frictional force acts on A towards right side. Okay. So these are the direction of frictional forces. One more force is there, that is its weight down, and the reactional force, the force exerted by B on A, is normal reaction, let it be N2. So N2 is equal to, we have N2 is equal to MAG. Okay, so when does the block A starts slipping on the block B? So to answer these questions, okay, let us see. So these are the directions of frictional forces, and you draw the limiting values. Okay, limiting values of range of frictional forces. Limiting values or range of frictional forces, range of frictional force, friction. Okay, so I will draw this one. I need this space here. Okay, now see, limiting values of or range of frictional forces. So there is no friction between this block B and this smooth. So there is no friction here, but there is a friction between A and B. Okay, so what is the frictional force? That is Fs. When the block A is at rest, the frictional force's nature is static. It is given by mu s. It is mu s into n. Its normal reaction is N2. So mu 2 N2 frictional force. That is, what is mu s? 0.2 into N2. N2 is MAG. I will write here one more step. Mu s MAG. So that is mu s is 0.2. Mass of A is 10 kg. G is 10. let it be. So this is 2 into 10, 20 newtons. So the static frictional force is 20 newtons. Similarly, kinetic frictional force is mu k n2. That is mu k. What is mu k? Mu k n2 is mag. Okay. Similarly, what is mu k? 0.1 into 10 into g is 10. So this is 10 newtons. Okay. So when the static frictional force between the block A and B is 20 newtons, and the kinetic friction between the block A and B is it is 10 newtons. Okay. So these are the limiting values of range of frictional forces. The next step is, see, here when the force acts on this block B, external force, this block A is also tends to move. Why? Can you say? Because of frictional force. When there is no friction between these two blocks, it will slip. So because of frictional force, the block A also moves along with the block B due to frictional force. So what is the force acting on the block A? Is only frictional force, because in this direction, y direction, these two are cancelled with each other. There is no motion in vertical direction. So the block A has a tendency to slide in horizontal direction. So the only force acting on the block is frictional force. So what is the maximum value of frictional force? Then you find maximum acceleration. Before going to write maximum acceleration, you write maximum acceleration. Maximum acceleration of the block. Maximum acceleration of the block A. How much? So the force acting on the block A is the force block A. I will write here. Block A moves due to frictional force only. Due to friction only. If there is no friction, it won't move. So block A moves due to frictional force only. So what is the maximum acceleration of the block A? So Newton's second law, acceleration of the block A is, maximum acceleration of the block A is force acting on it, maximum force by its mass. Okay, from Newton's second law, force by mass. So what is the force? Fs is 20 newtons, and the mass of A is 10. So that is 2 meter second to the power minus 2. So 20 by 10, 2 meter second inverse 2. So this is the maximum acceleration, AM. I represents AM. Acceleration of A is maximum, is 2 meter second to the power minus 2. So this is the maximum acceleration. So when this force varies according to the law, F is equal to, it is given by 10t. So it varies according to the law, F is equal to 10t, where t is time. So it is a variable force. So this is the maximum acceleration. So when this force, maximum force in order to move these two blocks together is maximum force is maximum acceleration into, you take these two as a single body, then maximum force acting on the block A is maximum force. I will write here, maximum force in order to move both blocks together together is F maximum is equal to mass of A into mass of B into A max, acceleration of A maximum. So use this formula. So what is the maximum force? Mass of A is 10, mass of B is 20, 10 plus 20, 30, 30 into, what is acceleration of A? 2. So that is 60 newtons. So when this magnitude of this force will be 60 newtons, so what happens, this block, since there is no friction between the ground and the block B, first B starts slipping because there is no frictional force acts on it. Okay, so there is no friction between B and smooth. So when the force is acting on that, just first A slips and A slips, so A starts moving and B is also starts moving along with A. So both move together. Until how long they will move together? Until the maximum force is, they acting on it is 60 newtons. So when the force is 60 newtons, what is the time? So F is equal to, if you substitute this value, F is equal to F maximum is 60 newtons. How much time it will take? So I will write here. Okay. So I will write here. So you compare this Ft. So F maximum is equal to, when F maximum is equal to 60 newtons, so F is varies according to the law. 10T is equal to 60 newtons. So T is equal to 6 seconds. So until 6 seconds, both blocks move together. So this acceleration is also a variable. So I want the acceleration of the block until this 6 seconds. So what you will get, acceleration of the block is, I will write here. Okay. So I need this space. So I will take this one. Okay. So acceleration of the block is, so what is acceleration of the block? Common acceleration, use Newton's second law. So applied force is 10T. Applied force minus frictional force is resultant force ma. So mass of A into mass of B into A. So what is acceleration? Common acceleration is F 10T minus frictional force is, once the block starts, what is the nature of the frictional force? It is still, it moves along with that. That means the block B does not slide. It does not slip. So the frictional force between these two blocks is 20 newtons. So it is 20 newtons static by mass of A and B. So mass of A and B is 30. You take these two as a single unit. So that will becomes, acceleration is equal to T by 3 by 2 by 3. Okay. So this common acceleration is, we have, okay. So the common acceleration is A by 2 and this is total mass. We want the acceleration of these two blocks. So what is the common acceleration? You will get AT, that is T by 3. Force is given as 10T. Yeah. So 10T minus acceleration is T, acceleration is equal to T by 3. So the frictional force until they move with a common velocity. There is no friction here. So here, see, when the both blocks move together, I will write this one. Here, when the both blocks move together, there is no friction. So the block just begins to slip. So there is no frictional force. Okay? This block, between these two, there is no friction. So what is the applied force? Is F. That is 10T. This F is 10T. That is mass of A and B is 30. What is acceleration? So A is 10T by 30, T by 3. So this acceleration is A is equal to T by 3. Because this block, there is no friction between these two. So this block B, it will slide together along with A. A is also moved together. So with an acceleration T by 3. How long it will accelerate? Common acceleration up to 6 seconds. Okay? If this force exceeds this maximum value, this applied force varies with respect to time. Okay? If it exceeds a certain maximum value, that is F max, these two blocks will detach. So this A begins to slip. A begins to slip over the block B. When it will begins to slip over the block B, when the force acting on this block A exceeds this 60 newtons. Okay? So I will write this one. I will take this space. Okay. So what is the maximum value of frictional force at which the block will start slipping? The answer is 60 newtons. So what is the question? For the first question, answer is, what is the first question? You check the question. First question. What is the first question? When does the block A starts slipping on the block B? When does the block A starts slipping on the block B? For that question, answer is how much? When does? That means time. After 6 seconds, A slips on B. Okay? And what is the maximum value of that force? So when at the time of slipping, what will be the force F and the acceleration just before slipping? So at the time of slipping, magnitude of force is 60 newtons and acceleration at that time is T by 3. T by 3 means T becomes 6 seconds. 6 by 3, it will become 2. So when the acceleration at the time of slipping A is 2 newtons. So, okay. The next one is, that is the answer for the first question. Second one is, what is the second question? When the force is increased beyond the value obtained the part A, what will be the acceleration of A? So that is the second question. So if F value increases, if F greater than or equal to F max, block A slips on block B. Okay? Block A starts slipping on block B. So when F exceeds this 60 newtons maximum value, so this F maximum is 60 newtons. What happens? We want acceleration of the block A. So it's once it starts slipping, acceleration is, so you draw the FBD. So FBD of A, the only force acting on it is frictional force. Once it starts slipping, it has kinetic friction. So what is the acceleration of this block? So I will draw once again the FBD of A. So you have only K. So what is Fk? Fk is, I think, 10 newtons. 10 newtons. So what is the mass of A? 10. So Fk is 10. Fk is 10. So what is its acceleration? It will become force by mass. Okay. So what is acceleration of A? Acceleration of A is equal to force acting on it by its mass. So force acting on it is, once the block starts slipping, kinetic friction, nature of the frictional force changes, that will becomes kinetic. So 10 by mass is 10. So its acceleration becomes 1 meter second to the power minus 1. So this is the answer for B. Okay. What is that question B? What is the acceleration of the block A? What is the, when Fx is increased beyond the value obtained in part A, what will be the acceleration of A? So answer is 1. Okay, this is the answer for B. So still I have one more. At that time, what is the acceleration of B? So at that time I want acceleration of B. So what is the force acting on it is F is equal to 10t, and the frictional force is Fk. So its acceleration is net force 10t minus Fk. What is Fk? 10 by what is its mass? Mass is 20. Acceleration of the block B is, when F value exceeds this maximum value, acceleration of B is t by 2 by 1 by 2. Okay. So this is acceleration of the block B after, if F exceeding this F maximum value. Both blocks detaches and they are moving separately. The block B is moving, but the block B is sufficiently long. So the block A moves on the surface of B. Okay, because B is sufficiently long with an acceleration. Here t is a function t which varies with the time. Okay, I want to now draw AT graph. Okay, see how I will draw AT graph with the help of this information. Okay, so last one is you draw AT graph. So what is AT graph? See, t versus A. I will draw. I will take this space also. So now the entire one I will explain. So you listen. This is the story. Okay. T versus acceleration. So when the time t is equal to 0, force acting on it is 0. So both block will be at rest. Once the block up to 6 seconds, both blocks will move with a common acceleration. Acceleration becomes t by 3. So it is a variable. So it is a straight line passing through origin. Up to what time? 6 seconds. So up to 6 seconds, both block will have common acceleration. What is that acceleration? T by 3. T by 3. T is the time here. So when time is 6 seconds, 6 by 3, 2. So acceleration becomes 2 meter second inverse. At this instant, the force acting on the body is 6 into t. 6 into t, 6 seconds, 60 newtons. So when the force acting on the block is 60 newtons, then the both blocks move together with the common acceleration. That is t by 3. Suppose you want acceleration at the instant before 6 seconds. Suppose you want acceleration at 3 seconds. So what you substitute? 3 by 3, 1. So acceleration becomes, this is the slope. So this is the acceleration. Okay, acceleration becomes 1. Okay. Suppose when F exceeds the 6 seconds, okay, force exceeds the, what is the acceleration of A? Acceleration of A becomes 1. So it will slips. So this is 2, this is 1. So this is acceleration of A and it is constant. Okay, so it won't change with the time afterwards. Why? Because the only force acting on the block is kinetic. It is independent of speed. So its value is 1. Then this is the acceleration of the block A after slipping. Now I want acceleration of B when F exceeds 60 newtons. That is 60 newtons. Acceleration is variable because these two blocks have different accelerations. Okay, acceleration of B is t by 2 minus half. When t is 6 seconds, 6 by 2, 3. 3 minus 1, 3 minus half, 2 and half. That means 2.5. So when if it exceeds this value, the acceleration of B increases to 2.5 magnitude meter second to the power minus 2 scale. Okay, and again it starts increasing like this. So it increases with the time. So this is acceleration of B, which is given by, according to the law, t by 3 minus half, according to this equation. Okay, suppose you want acceleration of B after 12 seconds. 12 by 3, 4 minus half, 3 and half. That means 7 by 2. 7 by 2 means 3.5. Okay, like this. So the acceleration of B varies with respect to time after detaching. So this is the story behind this problem. Okay, once again I will explaining, you listen carefully. So before 0 to starting up to 6 seconds, both blocks will move together with variable acceleration t by 3. So this block will stick to this block with the help of frictional force. Since the block does not slide, okay, on the block A. Once it exceeds this maximum acceleration of this block A, what is the maximum possible acceleration of the block A? 2. So 2 into, that means if it exceeds 60 newtons, this magnitude of force, then this block A starts slipping on the block B. Until 6 seconds, it moves together with A and B will have a common acceleration until 6 seconds. At that instant, force acting on the body is 60 newtons. Once after crossing 6 seconds, the magnitude of force, applied force, increases beyond 60 newtons. Then what happens? This block slips, just starts slipping. At that instant, the force acting on the body is 60 newtons and the time becomes 6 seconds. Beyond that, A has acceleration constant 1. It has constant, it won't change with the time. Constant because the only force acting on the block is kinetic, that is 10 newtons. Hence its acceleration is 10 by 10, 1. And the acceleration of B is variable because the force acting on it is time. It depends on time. Hence it increases continuously with the applied force. Clear? Take this. Okay, you take another problem. Block A. So there is another block. Block on blocks we are discussing. So block B has 10 kg and block A is placed on block B, which is also having 10 kg. Okay. The coefficient of friction between mu s between A and B is 0.6 and coefficient of kinetic friction is 0.5 and between these two is mu s is 0.2 and mu k is 0.1. So this ground is a rough surface. So it is having a friction. There is a friction between the block B and the surface. There is a friction between the block A and the B surface. Their limiting values are given. Now this is a given problem. Okay. Now the force F acts on this block A. Let it be F. Okay. Mu S. This is external force F. So mu S is 0.6. Okay. Between these two surfaces. So external force. Now this block A is placed on block B, which is rest on the horizontal ground. Now the problem. Block A is placed on another block B. Another block B, which rests on a horizontal surface, on a rough horizontal surface. Rough horizontal surface. Horizontal force F is increasing, so that external force is increasing gradually. Okay. Find the maximum value of, so A, find, you have the following questions. Find the maximum F so that none of the blocks moves. None of the blocks move. Okay. Which force? Okay. Which block starts first? So which block starts sliding first? That is the question. Second one, B. Express acceleration of each block as function of F. As a function of F for all positive values of F. For all positive values of F. Okay. If C, F is equal to 10t, draw AT graph. Okay. Draw AT graph. This is the problem. Okay. Now you check once. So you first draw this. Okay, this is the problem. So block B is placed on rest on a horizontal surface. F is increasing. So you first draw the direction of frictional forces. So direction of frictional forces. Direction of friction first you find. What is the direction of frictional forces? B. External force is A. First you draw the diagram of A, because external force acts on it A. So this is F. The friction opposes A. So that is acts in this direction, frictional force on A. So now its weight mg down and normal reaction is up. Let it be m1. So this frictional force, let it be F1. Okay. So under you draw this FBD. This is FBD of A. I want FBD of B. FBD of B. So what are the forces acting on B? So there is no external force. The force acting, frictional force acting on A is towards left. So the frictional force acting on B is towards right. That is frictional force F1. And it is opposed by the frictional force. These two move together. Okay. So the direction of frictional force on the block B, there is also frictional force between these two. So it is a self-adjusting, its direction may change. If this is applied force on this block B, the frictional force on the block B between the ground and the surface opposes its motion. Let it be F2. Okay. So these are the FBDs of direction of frictional forces. Now next one is, what is the range of frictional forces? Range of frictional forces. Range of frictional forces between A and B, that is F1. So F1 between A and B, between A and B is F1, F1S. So static frictional force, that is mu s mg, mass of A into g. So that is what is mu s? 0.6. What is mass of A? 10. G, let it be 10. Okay, it is 6 into 10, 60 newtons. Okay, here G you have to take in this problem you assume G is 10. Okay, let it be 10. Okay, now that is, what is mu1k kinetic frictional force? Kinetic frictional force is mu k into mass of A into G. What is mu k? 0.5 into 10 into 10. So it is 50 newtons. That is kinetic. What is F2? Next one. F2. Okay. Next I will take this one. Frictional force between B and ground. B and ground. There is no, here it is not smooth. It is rough. So frictional force F2S. Static value is, you have to weight total weight. Okay. So 10 plus 10, 20. Mu S into mass of A plus mass of B into G. Okay. So that is mu S is how much it is? 0.2. 10 plus 10, 20 into 10. So it will become 2 into 20, 40. So 40 newtons. Okay. Next, F2k. So what is F2k? Mu k into mass of A plus mass of B into G. So you will get 0.1 into 20 into 10. So it will become 20 newtons. Okay. So these are the possible values of frictional force between the blocks. Okay. Now you check whether this maximum value possible acceleration of this block B. The next step is, in the first step you identify the direction of frictional forces. In the second step, you find its range of frictional forces. In the third step, you find the maximum acceleration of the lower block B. Okay. Here block B moves due to frictional force only. Due to friction only. Because there is no external force on the block B. Okay? There is no external force on the block B. Block B moves along with A due to frictional force only. So what is the maximum value of frictional force? The external force acting on it and maximum acceleration. So what is the maximum static frictional force acting on the block B? Okay. So what is the maximum frictional force acting on the block B? Okay. What is the maximum possible value of frictional force? So maximum acceleration of the block B. So it is F1 is how much? F1 is 60 newtons. Okay. B 60 newtons. What is F2? F2 maximum value 40 newtons. Isn't it? Once it will move, it will become once the block starts along with A, it has kinetic. So F2 kinetic is 20. So 20 newtons, which will act opposite to this. Okay. Once the block moves, the kinetic frictional force exists between the block B, between ground and these two. Okay. Once the block starts B along with A, the maximum force is 60 newtons kinetic frictional force, and this is 20 opposes. So 20 minus resultant force, what you will get? Resultant force is 60 minus 20, 40. 40 by mass is 10. That is, it will becomes 4. Okay. So what is the maximum possible acceleration of B? So it is maximum possible acceleration of B is force F1 minus F2k by mass of B. Okay. That is 60 minus 20 by mass of B is 10. That is 40 by 4 meter second to the power minus 2. Okay. So that is maximum possible acceleration of sequence of sliding. Okay. Let us see this sequence of sliding. The smaller the limiting frictional force B and the ground, so it will start sliding first. So which one starts sliding first? So that is the question. Okay. So which one has the limiting frictional force? This force is a variable. What is the limiting frictional force? For first block A and B is 60, and between B and the ground it is 40. So it is less. Between these two static frictional forces, it is 40. Between ground and the surface is 40. Between A and B is 60. So which one just starts is block B. So for that question, answer is block B. So sequence of slipping, smaller is the limiting frictional force between B and the ground, so it will start slipping first. So that is the answer for that question. Then both will move together till the B reaches the maximum possible acceleration 4. Okay. So next one, I will take this one, this space. So So I will write smaller is the limiting frictional force, smaller limiting value, limiting frictional force, limiting friction between B and ground. B and ground, since this is the reason, since smaller is the limiting frictional force between B and the ground, so it will starts. So B will starts slipping, will starts slipping first. So this is the answer for the question A. Which one starts slipping first means the answer is block B will start slipping first. The next one. Then both blocks will move together. So I will take this space. Remember these values because I need this space. Maximum acceleration is 4. And one more is, it is, so then both blocks will move together till acceleration of B will reaches maximum possible. Then both blocks move together until acceleration of B until maximum possible acceleration is B, until acceleration of B reaches 4, reaches value 4 meter second to the power minus 2. Thereafter A starts sliding. Thereafter A starts sliding. Okay. So the first one is A. Till the F reach limiting frictional force limiting friction between B and ground. Okay, between B and ground, none of the blocks moves. Okay. Okay. So see here in the first case, the answer for the first case is till the F reaches the limiting friction force between this block and the ground is limiting friction is 40. If the applied force is equal to 40 newtons, the blocks does not move. None of the blocks will move. Okay. The second case, if F less than or equal to 40, okay, none of the blocks moves means acceleration of A, acceleration of B becomes 0. Okay. So if F greater than or equal to 40 newtons, so what happens? This block starts slipping. okay, from the ground because of this force. Then these two behaves move together with the common acceleration until B reaches its maximum acceleration 4 meters second to the power minus 2. Okay, so when F greater than or equal to 40, both A and B will have common acceleration until B reaches its maximum acceleration 4 meters second to the power minus 4. Thereafter they have different accelerations. That is, both A and B will have different accelerations. So if you draw, when F greater than or equal to 40, you treat these two as a single body, and the force applied is F. So once this block starts, kinetic frictional force acts between them. Okay, so what is the kinetic frictional force between the blocks? What is the kinetic frictional force? You check. What is the value of kinetic frictional force? So what is the kinetic frictional force between these two, B and the ground? Kinetic frictional force is 20 newtons. So if you treat these two as a single block, the external force is F, and when these two moving together, the kinetic friction opposes. So the kinetic friction will opposes this one. Once the block starts, B, the frictional force, nature of the frictional force will changes. Static converts into kinetic. So what is the acceleration of this mass of the block? Let it be 20. You take together as a single mass. Then common acceleration is acceleration of A is equal to acceleration of B is equal to F from Newton's second law, F minus Fk by total mass. That is, F is F minus Fk. Fk is 20 newtons by mass is 20. So what is F? F is a function of t, that is 10t, isn't it? This F is a function of t. It is given as 10t minus 20 by 20. So this will becomes common acceleration is A is equal to B is equal to is a function of t, that is t by 2 minus 1. Okay. So up to, so when it will reaches this maximum value, so and this maximum acceleration value reaches to 4. So what is the acceleration for? If you use this one, F minus Fk. Fk is 20 is equal to ma. 20 into A is 4. Maximum acceleration of B is 4. So that is 80. So F becomes 100 newtons. So until 100 newtons, this force value reaches until 100 newtons. It is gradually increasing. When it reaches to 100 newtons, up to 100 newtons, these two blocks move together. Thereafter, it will have different accelerations. Okay. So Okay, I will take this space once again. So, acceleration of F is 100. That is, now until F is equal to 100, for 100 how much time it will take? 10 seconds, isn't it? F is given by 10t. I will write here. F is given as 10t. 10t is equal to 100. So t is equal to 10 seconds. Okay. To reach this force value 100 newtons, it will take 10 seconds. Okay. Thereafter, that is if last case, if F greater than 100 newtons, they will detach. These two will detach, and they have different accelerations. So when F greater than this, both blocks A and B have different accelerations. Suppose you want those accelerations, you draw these FBDs separately. So what is the FBD of A? FBD of A is, so A is 10 newtons, external force is F, which is opposed by this frictional force. So what is the kinetic frictional force between these two? It is 50 newtons. Static is, kinetic is 50 newtons, isn't it? So it is 50 newtons. Once the block starts, 50 newtons acts. So it has the acceleration of A is force acting on it, that is F minus Fk by its mass. Mass is M. Mass of A is 10. Okay. So this is acceleration of A is equal to F is 10t, Fk is 50 by mass is 10. So that is acceleration of A is t by t minus 5. Okay. So that is, it goes on increasing. And acceleration of B, you write FBD of B. Okay. The B block moves due to frictional force acting on it. So if you draw FBD of B, Fk will act in this direction, that is 50 newtons. I said frictional force is also action reaction pair. This kinetic friction acts on this block A in this direction, which opposes this external force, and this frictional force between these two surfaces, it will act in this direction. This block B moves due to frictional force K, which is opposed by this Fk, that is 20 newtons. So this is 20 newtons and this is 50 newtons. So what is acceleration of B? This 50 minus 20 by its mass 10, that is 30 by 10. That is, acceleration of B is 3 meters second inverse. It is a constant value. Okay. It won't change after further increasing F. Okay. This is the story of this variation of this F, the frictional forces. Okay. Now I will draw this AT graph by using this. So I will try to draw with the help of this data. You draw AT curve. Okay. See, AT curve. This is the time. This is the acceleration. Okay. So until F reaches the 40 value, both blocks does not move. That means their acceleration is 0. So until 4 seconds, the acceleration of A and B is 0. Okay. Then after 4 up to 10 seconds, both will have common acceleration, and that common acceleration will start What is the formula for this common acceleration? As I said, A is equal to, what is the common acceleration here? For this block B, we got, how much you got? T by 2 minus half, T by 2 minus 1. So until 4 seconds. Okay, so 4 by 2, 2. 4 by 2, 2, 2 minus 1, 1. So you have start acceleration from 1. Okay, having the magnitude 1. After 4 seconds, it will start from here. Okay, so it will increasing gradually like this. How long it will increases? This acceleration is given by the function t by 2 minus 1. So both will have common acceleration. It is a function of a time t. So until 10 seconds, both will have common accelerations. So beyond 10 seconds, so what is the acceleration here? At that instant, common acceleration is 4. Here it is 4. Because here it is maximum acceleration is 4. And then after exceeding this value, this both will detach and they have different accelerations. So what is the acceleration of A? Acceleration of A is t minus 5. So t is 10 minus 5. It will become 10 minus 5, 5. So it will start from 5. Okay. It will start from 5 and it varies according to the equation t minus 5. So it will start from 5 and then it increases according to the equation t minus 5. So the acceleration of A thereafter, after 10 seconds, it is a function of t minus 5. And further, what is the acceleration of B? Acceleration of B is 3 constant. So it will be 3 constant like this. So this is acceleration of B. What is its value? 3. Okay. T minus 5. Okay. This is the acceleration of B. So this is the graph. Further increasing the time, it won't change. Okay. But the acceleration of A goes on increasing. So this is the story of this block on block. So I explained this block of block. So the force is, now once again I am giving this brief introduction, you listen. So what are the questions here? The force acting on this block is, so once again I will repeat this question. The block A is placed on block B and rest on a rough horizontal ground. Horizontal force A is increasing gradually. Now what are the questions? Which block will have maximum force? Which block will slip first? Answer for that B. Okay? Until what force this block does not move? So until it reaches this maximum value 40 newtons. So until 40 newtons force, these both blocks will be at rest only. Okay? Then thereafter they move together. According to the equation, A is equal to t by 2 minus 1. So you have to treat these two as single block. They move together until 10 seconds. After then words, they detaches with each other. They have different accelerations. To get different accelerations, you have to draw this FPD of A and B separately. Clear? Take this.